So I hopped to number 17. I was trying to find ones that were different. So this simply just said what is the z score? So you just need to know the formula. X is the specific value they're talking about. The X bar is the average, and then divided by standard deviation. So we just plugged in 108 was the number he gave us. 122 is the average. 13 standard deviation. So z score is negative 1.1. Just remember, a z-score is basically taking a certain x value, then you're finding the z-score, but then that's not your answer when they say what's the probability percent. That you then would need to go to the z table in order to find the probability or percent. Okay. Now for this next one, you're using the equation to try to solve an unknown, an algebraic expression. So if we know that this is our equation, right, but they give us standard deviation, they give us a specific value, they give us our z-score, they want us to find the average. So we're just using the formula. We plug in what we know. We know the z-score is negative 2.14. We know the specific value minus, we're trying to solve for x bar. That bubble x bar is the unknown, divided by standard deviation of 84.10. To get rid of a denominator, you can always multiply by what you see in the denominator. So I decided to multiply both sides by the denominator, 84.10. On the right side, it would be gone. So then on the left, you would get negative 201.84. On the right, you would have 317 minus x bar. We're trying to isolate that x bar. So we then subtract the 317. We get negative 519.18. But then we get rid of this negative 1 in front of the x bar. So when we divide by that, we get a positive 519, and that is the average cost. Now, 19 on, those problems are a little bit harder. So 19 and 23, we use this picture up here. I always like to draw the curve, whether I'm using z-scores or not, whether the values are increments on this chart or not at specific spots. So the process is the same. We just have to do an extra 2 steps if our increments are not on the chart and it's not easy to add the percentages in the regions. So if we're asked for the percent for x values between 7 and 11, well, we look up here at the chart and 7's there, but 11's not a nice increment. So we know that this region, we know that if this is 34%, and this is 34%, we know that it's going to be at least 68, but we don't know what this little sliver is. It's not quite 13.5. So that's why we need to use our z-scores. So then we have to find the z-score value for 7. So we plug into the formula, 7 minus the average, 8.5 over 1.5 standard deviation. So that's negative 1. So we wrote that right here. And then z-score 11, we do 11 minus the average, 8.5, divided by standard deviation, we get 1.7. So that goes right here. So now that we do that, we're not done. That's not the answer. We do that, we find the z-score so we can go to the table. So when we go to the table and we look for 1.7, we get about 0.9554. When we go to the table and we look at negative 1, we get 0.1587. So if it says in between, we're taking the difference between the two. It's always big minus small to get the difference. So that would be 0.7967. If it asks for probability, that would be our answer, but it said percent, so we moved decimal 2 to the right. So our answer is 79.67%. Okay, so for number 20, it said probability, so we want to have decimal form for our answer. Now they again say x has to be less than 9.5. So since 9.5 wasn't a specific value on the chart, we have to find z-score. Now we know less is to the left of that, and we know that if the 8.5 is at halfway, if we're adding on a little bit more for the 9.5 on the right and going to the left, we know it's going to be a little bigger than 50%. So we first find the z-score. So we plug in the x value of 9.5 minus the average, 8.5, divided by standard deviation, 1.5, and we get 0.7. Again, that's not your answer. Z-score is not your answer. You can then just rewrite the probability of z being less than 0.7. That's essentially the same as saying x less than 9.5. X is the specific number, where when we then just replace with z and the z-score number, it's talking about the same statement. But we then need to go to the z table. And on the table, when we look for 0.7, we see the decimal. The probability is 0.7580. Remember, your table is always talking about less than. And since we are saying less than, what's the probability of this being less than 9.5, which turns into a z-score less than 0.7? The table gives us the answer, since table gives us answers to the left. Now, since they say probability, we just stop at 0.7580. If they said percent, we would just say 75.8%. Okay, so for number 21, approximate number of students. So we first need our decimal, and then we need to multiply by the original amount of something, right? So process is the same. They're just a little bit longer. So it says, how many people will have a shoe size greater than 6, right? So, okay, 6 again, if we look back at our chart, or it's not on here, isn't an exact increment. So we then find the z-score using the z-score formula. And then we say, okay, z needs to be greater than negative 1.7. Again, the negative 1.7 is not our answer. That just helps us go to the then z table. On the table, it says 0.0446. Now, the chart is always for less than. So because our symbol says greater than, we have to do 1 minus the value on our chart. If it says greater than, you always have to do 1 minus the value on your z table. So that's why we get 0.9554. So that is the decimal, the probability. So we take our decimal, the probability, and then we multiply it by the original number of students, 36. And that's how we end up with 34 students. And that makes sense. 34 students have a shoe size 6 or larger. Okay, and then the last one, 22. So again, if we're trying to find values between 8 and 10, it says x, so we have to find those z-score values. We use the formula, we get negative 0.3, and we get 1. Then we have to go to our table, and at negative 0.3, we get 0.3821 probability. At 1, we get 0.8413. Since it's in between, we take the difference. So the probability would be 0.4592. But to find an approximate number of something, you take that decimal or the probability and you multiply by the original amount. And we get about 16 students lie in that region. Now remember, if it's something that's just set up for you, like probability of having a z value less than negative 0.3, well, that's easy. It says less than. Your z table literally tells you the less than values, and you would just scan for negative 0.3, and your answer would be 0.3821 when you look on the table. That would be your probability, and your percent would be 38.21. So if it sets it up for you with that z, the z-score, you don't have to do any conversion. Just look at the table and you're done.